Okay, good morning, class. Why so sad? After you heard about the highest mark is. Alright, so basically you guys had some homework, correct? The homework was on exercise 2.5 or 2.4. Right, in 2.4 you have to do the second column, correct? Right, any problems with 2.4? Any issues with 2.4? No? Then you have to do exercise 2.5. 2.5 you have to do the first column. Correct? Right. Any problems with the first column? Yes. What is the first problem? Sorry? K, 1K. Number 1K. Anything else? In number 1? Now in number 1. So that's 1K. Sorry? Sorry? A. Pull out my calculator. Sorry? A. Listen, you guys mustn't be shy to ask, okay? Now don't tell me now, all the sums is the problem. Then there's something wrong with you. Okay? But if you don't understand, let me know. So it's A and K. Anything else? Okay. So we'll cut from number 2 afterwards, okay? So in number 1A, the question says simplify. Okay. So we got 20 to the exponent 3 times 25 squared times 4 over x 7 to the 10 to the exponent 7. So what we're going to do is we're going to break up 20, 25, 10 and 4. So all those numbers can be broken up there. All its bases there. So we'd say 20 equals shift factorize. Oops, shift factorize. So 20 can be written as 2 squared times 5. 25 the same, probably 5 squared. 25 is 5 squared. Then 4 can be written as 2 squared. And 10 can be written as 2 times 5. Okay. So 20 we said is going to be 2 squared times 5 raised to the 3 times 5 squared raised to the 2 times 2 squared, and this is all over 10, which is 2 times 5 raised to the exponent 7. Okay. So now since something raised to the high exponent, a base raised to the high exponent, we multiply the exponent. So 2 times 3 is 6 times 5 cubed times 2 times 2 is 4 times 2 squared all over 2 to the 7 times 5 to the 7. So when you multiply and bases are the same way, add the exponents. So it's going to be 2 to the 6 plus 2 minus what? 7 times 5, 3 plus 4 minus 7 times. It's only 2's and 5's. That's it. Okay? So what is 6 plus 2? It's 8 minus 7 is 1 times 5. 2 plus 3 plus 4 is 7 minus 7 cancels. So it's to the 0. Anything to the power 0 is? So it's 2 times 1 is 2. So where did you go wrong, Michael? 4 times 5. But did you use that option of the calculator as I showed you yesterday? Okay. Anything else? Then we're busy with K. Again, we're going to break these bases up into products of its prime factors. So 12 again can be written as 12 can be written as first equal, shift factorize 2 squared. 9 can be written as 3 squared. You just go through the same notion there. 36 is 2 squared times 3 squared. And then 8 is 2 cubed. You just do that to be sure, or you don't know how to do it, you just follow the steps on the calculator. Why are you laughing, Michael? Yes? No. Every time I look at you laughing. You got that, you know that face that laughing. But it's fine, don't worry. It's nice. Alright, so let's go. 12 can be written as 2 squared times 3, n plus 1, times 3 squared, 2n minus 1, over 2 squared times 3 squared, n times 2 cubed, 1 minus 8. Okay. Who asked this question? You got that? Nice. So what's this going to be now? 2 to the 2n plus 2. Many people make that mistake. They write 2n plus 1. Is that your mistake? They don't multiply that 2n. They only multiply it with the n, but not with the 1 there. Times 3, there's must have 1, so it's n plus 1. Times 3 to the 4n minus 2. Over 2 to the 2n times 3 to the 2n times 2 to the 3 minus 3. Okay. So what do I do now? You're multiplying and bases are the same. We add the exponents, not so. So this base, and that base must be brought together, whilst those bases there, whoops, gets brought together. Okay? Why? Because the bases are the same. So it will be 2 to the 2n plus 2 minus 2n minus 3 plus 3. Okay? Times 2. No, 3. 3 to the n plus 1 plus 4n minus 2 minus 2. You all agree with that? So that will simply be 2n minus 2n plus 3n is 3n. You all agree with that? 2 minus 3 is minus 1 times 3. For n plus 4n is 5n, minus 2n is 3n. 1 minus 2 is minus 1. What do you notice here? Exponents are the same. So I can bring the bases together. So this can be written as 2 times 3, 3n minus 1. And what's 2 times 3? 6. The 3n minus 1. Okay. So we already picked up the mistake there of us. Did anybody make another mistake here in the sum? Yes, Michael? So you got up until here, this answer. Good. But now you have to conclude it. Anybody else? No. Okay. From that step to final step is 1 mark. Okay. So here for the sum is probably like 5 marks or something. 5 or 6 marks. No? Alright. Let's carry on. No problem with O, no? Number 2, any issues there? Number 3? Sorry? G. G. Anything else? What? B. What? E. So G and E. Anything else? Alright, so the question says, find the value of the missing factors A to H that will make the statements true, or these statements true. So, to make either subject of the formula, or to each standing on its own, I must divide both sides by 2n. So that cancels. So E is equal to, when we're dividing and bases are the same, what do you do to the exponents? You subtract, so it's 2 to the 3n plus 1 minus n. So it's 2, 3n minus n, 2n plus 1. Who asked for E? Where did you go wrong? So how did you do A? You just guessed. So you just look what must be added to that to give you this. No? What must be, okay? But that is the, you're going to do it in steps. No? It's going to be the way to do it. So let's apply the same idea to G. How do I get G on its own? We divide by 3 times 5 to the n. 3 times 5 to the n. That cancels. So G equals. So 3 goes to 3 once, 3 going to 18, 6 times. Times 5. 2m plus 1 minus m. And why? Because when we divide here, bases are the same, we subtract the exponents. So 6 times 5 to the m plus 1. Okay. Any confusion there? No? For homework, I would like you guys to do exercise 2.5, the second column. 2.5, the second column. And that's on page 48. So the heading for today is simplifying exponential expressions using factorization. And that's on page 49. So we're told when simplifying expressions in exponential notation, where addition and subtraction are used, you cannot simplify using one of the laws of exponents. Factorization allows you to simplify the expression. Okay? To factorize, you need to be able to reverse your basic exponential laws. You may also need to factorize numerical bases to simplify further. Okay, so that's basically your introduction to these sums. So we're going to start off with an example. This example 1 on page 49. So 15. On the same page, okay. So looking at this here, we've got 3 to the x plus 3 to the x plus 1 in example 1. Could we add the exponents there? No, because the law of exponents is when we're multiplying and bases are the same, we're going to add the exponents. We're not multiplying, nor are we dividing, nor is the base raised to an I exponent. Okay, so none of those laws of exponents can apply there. However, There's a plus or minus between it. What we do is we tend to factorize it. Okay. So what we do is, this step is not needed. Many do the step without what I'm going to show you now. But over the years I just developed doing it this way, because why, the average to weaker learner always has a problem factorizing. Okay? So if you are a learner that can do it without the first step of factorization, it's fine. You don't lose a mark. Okay? So what we do is, we know that if you've got 3 to the x times 3 to the 1, and I needed to simplify this, what would it be? It will be 3 to the x plus 1. So that means to say that 3 to the x plus 1 is also equal to 3 to the x times 3 to the 1. You guys understand? What if I add 5 to the 2x minus 3? That can be written as what? In factor form. 5 to the 2x times 5 to the negative 3. You guys understand? What if I got 17 to the 3 minus 2x? What would that be? 17 to the 3 times 17 to the negative 2x. You all understand? So I'm going to use that idea now to simplify this out. So number 1, they ask you to factorize and simplify. We have 3 to the x plus 3 to the x plus 1. So we got 3 to the x plus. That can be broken up into what? 3 to the x times 3 to the 1. Not so? So 3 to the x can be taken out as a common factor. Not so? So if I take out 3 to the x out as a common factor, what am I left with? If I take 3 to the x out, what am I left with in the first term? You're left with a 1. Why? So you took the whole term out as a common factor. Not so? So you got x plus x times 3. We'll make it that 2 there. X squared. What is common here? What are we left with? 1 plus 3x. 1 plus x times 3, which is 3. You understand? Okay, remember that products is the reverse of factorization is the reverse of products. Okay? So whenever you take out the whole term as a common factor, you're always left with a 1. That's what I tried to illustrate here. So here I took the whole term out, so I'm left with 1. If we take 3x out here, what am I left with? How are you left with 1? You're left with 3. And what's 1 plus 3? Well, yes, it sounds like you guys are going to do well in the next exam. And we always write the coefficient in front. Not so? So it's going to be 4 times 3. Okay, guys, don't sound convinced. Let's do it again. So what we do is we say, okay, there's a plus or minus between. Right? So what do we do? Factorize. So make a first note there, we're going to factorize. Oh, sorry, not factorize. We're going to break the powers up. Okay? So what did I do? So we're going to break the powers up, okay? Namely that one there. Second, so if you're going to break this up, what we have is 3 to the x plus 3 to the x times 3 to the 1. What is the next point you need to say there? You're going to take out the common factor. So that's your next term. The next step. Take out the common factor. Okay, so we'll take out the common factor of 3 to the x. If I take out 3 to the x, what am I left with? 1 plus 3. We took that out, we took the whole term out, we left with 1. Right? We take 3 to the x out, the second term I'm left with 3. If you want to say 1 times 3, it's the same as saying 3. Okay? The third point is simplify inside the brackets. Simplify inside the brackets. So we simplify, that's going to give us 4. And to write, we never write 3 x3 like, not so. We always write the coefficient in front. Not so. So that would be 3x. In this case it will be 3 times 3 to x. Can I multiply 3 and 4? Yes? You can't. Why not? It's to do with that exponent. You see that exponent on the 3. Because of that, we can't multiply these bases. Can you see that, people? So your answer is going to be 4 times 3 to the x. Let's look at example 2. It says factorize and simplify. Factorize and simplify. So what can be done here? What is common in the numerator? M cubed. What are we left with? 1 minus m. You all agree with that? Because m cubed times 1 is m cubed. M cubed times negative m is negative m to the exponent 4. You all agree with that? And this is all over what? M cubed. Now what do we do? Cancel out. So what are we left with? 1 minus m. Let's look at example 3 on page 49. Okay, so there's example 3. Let's look at example 3 first. The question says simplify. We got 7 times 2 to the x minus 3 times 2 to the x plus 1 over 2 to the x minus 2 to the x minus 1. So what was the first step we said we were going to do? We're going to break up the powers, okay? So do that first. So the first 7 times 2 to the x, that can't be broken up. However, the second term in the numerator can be broken up and the second term in the denominator can be broken up. Not so? Right, so do that quickly. So what you should get is 7 times 2 to the x minus 3 times 2 to the x times 2 to the 1 over 2 to the x minus 2 to the x times 2 to the negative 1. Now what do we do? You take out your common factor of 2 to the x. Not so. In the denominator, also 2 to the x is a common factor. So do that quickly. So what do we get? 2x as a common factor. And I'm left with 7 minus 3 times 2 over. We took 2x out. If we take 2x out in the denominator, what are we left with? 1 minus 2 to the negative 1. Not so? What can happen now? 2x cancels, yes. And you simplify inside your bracket. So simplify inside the bracket quickly. So in the numerator is 3 times 2 is 6. 7 minus 6 is 1 over. What is 2 to the negative 1? A half. And 1 minus a half is half. 1 divided by half is 2. Okay. What's wrong? Is it wrong? Huh? Okay, now I feel better. Taking it right. People, let's look at the any questions with regards to this here? Any issues? No? Again, we'll do this one together. Example 4 on page 49. What are we going to do first here? We're going to break that one up, yes? And 3 in raised to the exponent 2. You can multiply those exponents up. Not so? So do that step for me quickly. So what would this be? 3 to the 2n plus 3 to the 2n times negative 1 over 3 to the n. Now what? Common factor. What is common in the numerator? 3 to the 2n. 3 to the 2n. What are we left with? 1 plus 3 to the negative 1 over 3. Okay, to the next step. So when we're dividing it, bases are the same. What do you do to the exponents? Subtract. So in other words, this will be 3 to the 2n minus n into. So you sort out inside our brackets. 3 to the negative 1 is what? So it's 1 plus 1 over 3. Not so? So this will simply be 2n minus n. What's 2n minus n? N. So it's going to be n into, what's 1 plus 3, 1 plus a third? 4. 4 over 3. Or 1 and a third, no? We're going to go with 4 over 3. But where does the coefficient go? In front, not so? So that would simply be 4 over 3 times 3 to the n. Or it could have been written as, can you see here? This is as if I'm dividing those bases. Not so? When we're dividing it, bases are the same. What do you do to the exponents? Minus. So this could also be written as 4 times 3 to the n minus 1 because there's a 1 there. Either way, you'll get the full marks. Okay? Any confusion there? Let's do the next example on page 50. Example 5 of this time. So we got 3 to the x minus 4, or minus 2, sorry, plus 3 to the x minus 1 over 3 to the x plus 3 to the x plus 1. Svista, you okay? So what's the first thing we're going to do? Break it up. Okay, so break it up quickly. Then what do we do? Take out the common factor. So take out the common factor. You all with me, no? So what do we do next? Simplify, we can cancel, yes. 3 to the x will cancel. You all agree with that? And then from there we must just simplify inside the bracket. Okay, so I'll give you a minute before I do it on the board. Alright. So we say 3 to the x times 3 to the negative 2 plus 3 to the x times 3 to the negative 1 all over 3 to the x plus 3 to the x times 3 to the 1. So what is now common? 3 to the x. What are we left with? 3 to the negative 2 plus 3 to the negative 1 all over 3 to the x into 1 plus 3. All agree with that? You got it? Right? So what happens now? 3 to the x cancel. So 3 to the negative 2, that is 1 over 3 squared, not so? Which is 1 over 9, plus 3 to the minus 1 is 1 over 3, all over 3 plus 1. You all agree with that? What's the LCM in the numerator? 9. So 9 must be multiplied by 1. The 3 must be multiplied by 3. And this must be divided by. So what is 1 plus 3? 4. So it's going to be 4 over 9 divided by 4 over 1. Which is the same as multiplied by 1 over 4. So what happens now? Cancel. So I'm left with. Yes? Okay, let's just go again. In this bracket you're referring to? Or the top one? Okay. This one here? We take 3x out here, I'm left with that. Not so? If I take this out, I'm left with that. So I'm left with 3 to the negative 2 plus 3 to the negative 1. Okay. The only time you're left with plus 1 is when you take the whole term out as a common factor. Okay. Any other questions? No? Right, so we have about 5 to 10 minutes left. So what we're going to do now is we're going to start your part of your homework is going to be exercise 2.6, the first column. So what I want you guys to do now is we'll start with 2.6 first. So we can start answering 1 or 2 questions before the bell rings, okay? Is that okay? So the homework is exercise 2.6, the first column, and that's on page 50. Pause the video at this point. Okay. So as indicated, the first 4 questions is answered already. Right, so number 1a. So you got 2 squared plus 2 cubed. Now we could have said that it's going to be 4 plus 8, which is 12. No problem, no? But let's use the exponential rule. So it's going to be 2 squared into 1 plus 2. What's 1 plus 2? What's 2 squared? 4 times 3 is? Or you can leave it as 3 times 2 squared. I don't know which way the answer in the textbook is. Okay. What did the textbook give us? 12. Okay. C. So that's going to simply be 2 to the x plus 1 minus 2 to the x. So what do we do first? We break that up. So it's 2 to the x times 2 to the 1 minus 2 to the x. What is now common? 2 to the x. What are we left with? 2 minus, what's 2 minus 1? 1. And 1 times any number would be that number. Okay, any real number will be that number. Can I take it off? Let's do E. You got 2 times 3 to the x minus 2 times 3 to the x plus 1. So what do we do first? You break this up. That would be 2 times 3 to the x minus 2 times 3 to the x times 3 to the 1. So what is common? 3 to the x. I'm left with 2 minus 2 times 3 to the 1. Not so? According to BODMAS, multiplication first. So it's 2 minus the 2 times 3, 6. So it's 3x times 2 minus 6, negative 4. Always write the number in front, so it's negative 4 times 3. Okay? You see you've done with G as well? Yes? Sorry? You did another way. That's fine. G, you can bring it to me now. No? You just explain G before you guys leave. So it's 2 to the m plus 2 plus 5 to the m plus 1. First we break up. So it's 5 to the m times 5 to the 2 plus 5 to the m times 5 to the 1. What is common? 5 to the m is common. I'm left with 5 squared plus 5. What's 5 squared? 25. 25 plus 5, 30. So that is also equal to 30 times 5 to the m. People for homework, or that could also be written as 6 times 5 to the m plus 1. Okay, this is another way of writing it. Otherwise that should be suffice. People, don't forget, the rest of the first column in this exercise is homework, and enjoy the rest of your day. Michael, can I just see that the answer you have?